The question says compare the relative stability of the following species and indicate their magnetic properties. Fine. And when we are studying bonding, we should assume that when they are talking about stability, this is a defect of NCERT, because actually stability can have a much more vivid meaning. But in this case, they are just talking with respect to strength of bond between two atoms. Honestly, they should have specified it, but as they are NCERT and they are free to do whatever they wish, science or not. This is with respect to only the bond strength and nothing else. Okay. We are supposed to find O2, O2 plus, O2 minus and O2, 2 minus. Wow, lovely species. Can we write down their MO configuration? Yes, let's do that. First, let us write it down for O2. O2 contains how many electrons? 8 plus 8, 16 electrons. Sigma 1s2, sigma star 1s2, sigma 2s2 and sigma star 2s2. There go 8 electrons. Now you have sigma 2px, pi 2py, pi 2pz. 8, 9, 10, 11, 12, 13, 14. We have 14 electrons booked. And we just have 16 with O2. And what are the next orbitals? Next orbitals are pi 2y, 2py and pi 2pz. And since there are two orbitals, degenerate orbitals having exactly the same energy, we just distribute one electron each and that's it. Oh wow. So O2 has two unpaired electrons. Yes, O2 has two unpaired electrons. Let's make a small table actually. We have O2, O2 plus, O2 minus, like this. Fine, we will live. So, bond order, because bond order will give us the relative stability and magnetic properties, number of unpaired electrons. If there are two unpaired electrons in O2 and bond order, how do we calculate bond order? Bond order is number of electrons in bonding orbital minus anti-bonding orbital by 2. Plus 2 minus 2, plus 2 minus 2, they cancel out. Plus 2, plus 2, plus 2. 2 plus 2, 4 plus 2, 6. Minus 1, minus 1. That is 4. What is this? I just did it orally. If you want, I can write it down. 2, 2. More 2, more 2. 2px plus 2. Py, pz plus 4. Minus plus 2. You solve this and you get 2. Okay, so the bond order of oxygen is 2. Yes, the bond order is 2 and it is paramagnetic. Oxygen is paramagnetic. Magnetic property, O2 is paramagnetic. That means it is weakly attracted by a magnetic field. Fine. What about O2 plus? In O2 plus, you just have to remove one electron. So I'll just take away one electron and make it 0. Wow. So this changes to 1 and this changes to 2.54. This is too good. Bond order has increased. Yes. Why? Because the electron which has been removed has been from outermost anti-bonding orbital. I'm sorry, this is pi star. This is pi star. I missed out on this. This is pi star by error. So, since these were anti-bonding orbitals, this is 2.5. It has increased. 2.5 and there is one unpaired electron. So is this also paramagnetic? Yes, this is also paramagnetic. Even if one unpaired electron is there, it becomes paramagnetic. So oxygenyl cation O2 plus also is very much paramagnetic. What about O2 minus, O2 2 minus? Let's do that. If you want to make O2 minus, actually, my dear, you would find that O2 minus contains 17 electrons. O2 16, add one more, you get 17. 2, 2, 2, 2, 2, 10. 11, 12, 13, 14, 15. I need to add 2 more. I can add 2 more here. Okay, why not in 2py? You can add in 2py also, no problem. Any one of these can have 2, the other one will have 1. What about bond order? Well, bond order gets reduced to 1.5. My God, because 2 extra electrons entered into antibonding orbital, the bond order has been reduced. Nice. Fine. But does it contain unpaired electron? Yes. Is it paramagnetic? Yes. So O2, O2 plus, O2 minus, all of them are paramagnetic. They very much are. What about peroxide? Peroxide is O2 minus, and that, my dear, contains 2 extra electrons, 16 plus 2, 18 electrons. We already had 17. If I add 1 more, this becomes 18. The bond order falls to 1. And do you see that there is no unpaired electron anymore? The bond order is less. And because it is less, it is diamagnetic, since number of unpaired electrons is 0. So as far as magnetic properties are concerned, O2, O2 plus and O2 minus are paramagnetic, O2 2 minus is diamagnetic. Fine. What about the stability of the following species? If the stability is just dependent on bond order, then higher the bond order, higher the stability. If we assume that, then we say the stupidest of them is peroxide, then comes superoxide, then comes O2, and then comes O2 plus. This is, as the bond order increases, the strength of bond increases. And if we are just taking the strength of bond as a measure of stability, which NCERT has assumed here, this is the answer.